Hey everyone, apologies about that. Once again, technical issues. Really badly when the VM keyboard just doesn't work sometimes. Really strange. I've been trying to figure it out. Eventually it works, but yeah. And then webcam issues, and it's been fun. But anyway, hopefully some of you are still around. Again, apologies for being so late. So in this session, what we're going to do is try to cover off some TLS things. So some tools around TLS, what it is, what it means, all of that. So I've got my little cheat sheet on the side here, so that's why I'm just looking there. So TLS, Transport Layer Security, which had a previous protocol called Secure Sockets Layer, SSL. SSL is dead. It went up to version 3, and then TLS kicked off with 1.0, then 1.1, 1.2, and we're now on 1.3. And TLS is designed to encrypt traffic between a client and a server. Now, one of the things that many people kind of forget about with TLS is, yes, it protects data. So, for example, someone's logging in, you're protecting against someone eavesdropping your username and password, but it also protects against tampering. This is also really important because often, sometimes people go, hey, the page is public, so why must I use TLS? Well, someone could then tamper with that, and you got things like fake news or start injecting additional content on that site. So you could inject things like bhooks, redirect your users to malicious sites. If it's a news site, just alter the entire news article, introduce fake news and that kind of thing. So even if a site is public, TLS is still really important. So trying to show you maybe kind of that quickly, and then we'll start diving into the tools. So here we go. If we go into Burp, Burp, you can kind of think of a man in the middle, machine in the middle, very rudimentary way. Ways you could do this is public Wi-Fi hotspots. So I have a Wi-Fi pineapple that I enjoy using. Someone connects to it, I can now start intercepting all their traffic. This has happened in the past where some, like I think one was Starbucks in South America somewhere. Their router got compromised. I can't remember the exact details, but someone compromised that access point and was able to, I think they injected a crypto miner. So that's a good example of what someone could do with malicious, starting your site's crypto mining. The other ways are like things maybe a bit harder, so DNS poisoning or ARP spoofing. Kind of those attacks are probably a bit more advanced. So what we have here is Burp, and I am going to connect my proxy to it. So essentially I'm pointing to Burp, which is the man in the middle. And one of the sites that I'm going to is http scripting.com. Now this site is over HTTP. So there's no certificates or anything to worry about. And as you can see, all loaded up fine. Now, what I'm going to do is I'm going to do some interception. And let's see what we can do with this page when I intercept. Intercept it again. Sorry, different keyboard. I'll just delete the cache. Because it's a HTTP page, it'll probably be cached. So I'm just trying to make sure I just click delete. cache. So off we go. I should now have an interception. So I do. And we will now intercept the response to this. Let's forward it on. Probably want to intercept that one. And there we go. So here's the first page. I think the render should hopefully work. Yeah. Okay. So let's start modifying things on the page. So let's look for scripting news and modify that. Scripting news. There's a title. We want to change the heading. I think this there we go. All right, so we'll change this to something like hacked. And so, and again, we could maybe make this in like 2222, and we'll make it Thursday, April 1st, and then April Fools top. Okay, so modified some content on the page. I mean, these are pretty benign. I don't know why there were 2 requests made, so probably going to look for this just in case. So let's just modify this as well, just in case. Sorry, I got system issues with devices not been playing ball with me. We're going to say this to 2222 April 1st and April Fools. Something like that. All right. So we should now see. So there we go. I've modified the content of the page. I don't know where the other one was, but you can see I've modified content on this page. I don't know why I didn't update these. Maybe there's some additional call being made, but still, the point is still there. You got things like this, which is a bit worrying. So there's a link, a login link to Twitter. So you could intercept that. Now, what you'll see here is an error. And this is why man in the middle is not possible when you got something like TLS in. So TLS is trying to make sure that you are connecting to the server that you anticipate you are going to connect to. And in order to do that, the server needs to present an identity, and it does that via a HTTPS certificate. Or not really not a HTTPS certificate, but a certificate over the HTTPS protocol. Now, you might be thinking, well, anyone could then just create their own certificate and present this. Well, this is where things like CAs come in. I won't go into full details. There is some content on my blog that I try to give a overview of how certificate signing works, how CAs play into it, all of that. But basically, your browser trusts a set select of CAs, and these are generally produced by the different browser vendors, so Google and Mozilla with Firefox, and you can also import your own CAs. So that's what we're going to do now. So go to localhost, you can download this CA. Now this CA is what the certificate authority, which is what CA stands for. Once you trust that CA can then issue certificates, and it's any certificate issued by that CA is something that your browser would trust, and it's all done via public key signing, that mathematical magic. So what we'll do is we'll import it. So if we go to settings, and I forget where it is, certificates, you can also search for it. So we want to import a authority, certificate authority. So import that, and we're going to trust websites, and away we go. So now if I refresh that, it works. And you can see the certificate. You can actually view the certificate here, and you can view all the details on the certificate. Now, see, signed by ports figure because I'm intercepting. Generally, this will be signed something like DigiCert or something like that. And then one of the other things with the certificate is a DNS name in the subject, alternative name. So this is the host name that you're attempting to connect to. So in this case, twitter.com, and the client will then match it to make sure that that certificate is for twitter.com. Otherwise, you could just simply go to any CA, request a certificate for a domain that you own, and then present that as your certificate to a server that you don't own. So it then makes sure that you're connecting to who you're expecting you're connecting to. But a word of caution, just because someone gets a certificate doesn't mean that they are a legitimate entity. By that I mean there could be phishing up malware still, or phishing or something like that. It just simply means that you're connecting securely to whatever end service. So if you got like phishing links, this is where attackers leverage this, because we've always trained users, look for the padlock, it's all good. Well, padlock just means it's secure. It doesn't mean that the site is actually legitimate. That's a bit harder, so you got to like look at things like the URL and making sure that it's not a phishing site, and there's a whole different thing to that as well, and different tools that you can use for that. For this session, we're just focusing on TLS. So that's hopefully a brief introduction of TLS. Now, what are the different tools that you can use? Well, it's all good that you can use a browser, as you've seen, you can use Burp, but there are some actual tools that you can then use to test things. So some of the tools that you can use are OpenSSLs. Now, OpenSSL is a very, very, very versatile tool. You can do many things with it. You can view certificates. You can actually even use it to create your own sort of CA, and then you can sign your own certificates, import that CA into your trust store, and then you can start issuing your own internal certificates. There are different tutorials online that you can look at that. I would recommend that's probably old way of doing things. You can use things like Step CA, which now uses Acme and does all that lovely automation, which is a fantastic thing. Again, that's on my blog. If you have a look at that, I think it's internal Acme server or something like that. That contains instructions on how to set up your own internal CA using Step CA that leverages Acme. So then you can use things like Certbot to start standing up Nginx instances and Apache instances and all of that lovely stuff, and get certificates like one-line command. But having said all of that, OpenSSL. So some of the things you can do with OpenSSL are things like actually retrieve a certificate. So in this case, let's actually see what Twitter's actual original certificate was like. So for that, you want to use a tool or plugin. I don't know what they call it in OpenSSL world, but as client, and you might want to connect to twitter.com. You can specify the ports, or you can leave it off. It'll do it by default. And you want to put dev now. You want to redirect dev now to it just so it connects, disconnects, and that means it's going to get the certificate. So if you run that, you can actually see different information about the connection. So it connects, it gets the certificate chain. Now, I'll come back to the certificate chain is related to the CA, and then the actual certificate, and then a bit of details about the certificate, and then information about the connection, the software suite. Again, I'll go into that in a bit. So just quickly coming on a certificate chain. Now, a CA certificate is no different from any other certificate from the service certificate in terms of its structure. The only difference is it's a special type of certificate. So within a certificate, there are certain flags indicating what a certificate can be used for. And one of those flags for CA is can sign certificates. And that makes it a special certificate. With certificates, you can chain them. So one certificate can chain another, can chain another, can chain another. And this is where you start hearing things like a root CA. So the root CA is kind of the top CA, and then that will have subordinate CAs or sub CAs. So in this case, DigiCert, TLS, RSA 1, SHA 256, blah, 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 CA. So this certificate signed this certificate, and this sub CA signed this. Now, your trust, as long as you provide that chain, the trust works high up the chain. So if I trust this sub CA, then I'm going to trust this. But if I then trust this root CA, I'm going to trust this. And by trusting this, I'm going to then trust this because this sub CA signed this certificate. But as long as that chain is presented by the server, so your client can actually work its way through it. So in this case, it can go, okay, signed by this CA. Okay, it's signed by that root CA. I trust the root CA, so therefore I'm going to trust it. If this wasn't there, then you get this certificate, say it's signed by this, but then you can work out who signed this. And by signing, you're actually looking at the signature on the certificate, not just this kind of stuff. But because that's all there, it can work its magic and work out that it's signed. Now, for the service certificate, you'll also see this command here. The certificate here and this text. Now, there's a format with this, and this is called an X509 certificate. And basically, always has a begin and end certificate like this. I think it's 59 characters per line. I can't remember the exact number of characters per line, but it's something like that. And then base64 encoded. Now, what you can do is actually pipe this command to OpenSSL, because guess what? You can use this tool to read X509 certificates. So what you would do is OpenSSL X509 to read it, minus text means just print it out as text, and a no out. If I didn't include the no out, it would display that certificate again. So if you now do that, you can now see the certificate itself and view all the details about it. Now, just a few things about certificates. So serial number is unique per CA. It's not unique for all certificates. It's only going to be unique per CA. And then issuer is the actual name of the CA that signed the certificate. So you've got country, organization, and common name. It's just kind of a friendly name. Certificates are valid between a start and end date. Very seldom will you see a certificate not valid because the not before hasn't come yet. I don't think I've ever seen that happen. But certainly one thing that happens often is expired certificates. So that means they're not after it's been in the past and that certificate's no longer considered valid. And one of the reasons why we expire certificates are things like trying to get certificates updated so you can get stronger algorithms, and so algorithms such as signing algorithms, and also rotating the private key. I'll come to this in a bit with private keys, but basically updating, refreshing that certificate. The subject provides a bit of meta type information about the certificate. Now, the common name should match the server name depending on the client. There's a whole RC spec of how this should work. Basically, if it's not in the SAN, then it should be in the subject. In the past, browsers always kind of use the CN as this. But if you look to the likes of Chrome, that no longer uses this field. It has to be in the subject alternative name as the DNS entry. But much like the issuer, there's other things like country, state, location, and organization. Next up is the actual public key. So this is part of the public part of the public-private keys. So this is the public key. It's published in the certificate. Anyone can have it. You can spread this out as much as you want. There's a lot of mass crypto stuff going on. So you've got different algorithms. So one of them is RSA. And your key length is indication of how strong your private key is as well. So in this case, it's 2048 bits, which is generally quite strong. The stronger is 4096. Weak ones are 1024. If you use these tools that I'll explain later, they'll tell you these kind of things. Now, the extensions is where I was mentioning earlier about how CAs are a special type of certificate. There is a extension, and yeah, I think it's CA signing or something like that, that indicates the certificate can be used for CA signing. But in this case, it's not. In this case, it can be used as a digital signature. So you can use the certificate to sign things, digitally sign things. And you can use it for as a web server authentication, which is what most TLS or every single TLS site would need this to say that you can actually use the certificate as an identity for TLS servers. And then you can also use for a client authentication. So with TLS web clients, what that means is you have something called mutual TLS authentication. So the client will connect to the server and say, okay, give me your certificate, validate that certificate, great. The server can then prompt the client and say, hey, you give me your certificate and I want to validate you. And in that case, there are different options depending on the server. It can either ignore it. So if no certificate's presented, it just carries on, or it's optional. So it will get the certificate and validate it. If it's not valid, rejected. Or actually, no, and if no certificate is presented, it will still carry on. And then there's required, like that certificate has to be valid and validated and all that stuff. Often this is used for things like authentication to sites, where some people use TLS client certificates for that. Paining, but sometimes they are. And it's kind of not really common these days. And then there's other metadata here. So CRL is your certificate revocation list. So this basically lists of all the certificates that have been revoked. Revoked being the certificate's bad, don't use it. OCSP is, I gotta remember, it's certificate stapling policy. It's basically kind of forming a part of the CRL. So CRL is just a giant list that will just download. And as you can imagine, as certificates get revoked, that list will just grow and grow and grow and grow. OCSP is kind of a real time where the client will try to connect, say, hey, is this certificate been revoked? Is it not? Yeah. Generally, they're just not that great. Okay, so here's that actual, but that was stating. So CA, so this is not a CA. Certificate transparency, so CTLogs, or certificates now that are issued by official CAs. So if you create your own CA, this won't be an issue. But if you're talking about things like DigiCert or Thought or anything like that, they have to do the certificates transparency when they issue a certificate. This came about when Google found out that there were domains were suddenly appearing with certificates, and they hadn't authorized. It wasn't them requesting those. So they came up with this thing called certificate transparency. It was actually a pretty clever idea. Every time a certificate gets generated, it goes into a log, and those logs are stored in multiple places. And then you can look up those logs. Another cool thing is you can have alerts on them. So what that means is you can sign up to these services using a domain that you want to monitor, and then you can see all certificates created for that domain. So that way you're going to be able to know if a certificate's possibly been issued illegitimately. So that's a whole concept around certificate signing, certificate transparency. And then the last is the signature itself. So this is what your browser would use, your browser or your client use to validate that this certificate has been signed by a legitimate, trusted CA. In the signature algorithm, there's different algorithms. SHA-256 is the checksum hashing algorithm, and you want to make sure that's 256 and above. So SHA-512 is also bit stronger. And then there's different ones that you get elliptic curve and all that kind of stuff. In this case, it's just RSA. So that's just an overview of a certificate and all the fields there that you really need to be concerned about. All right. So this looks like the wrong Java. I'm assuming everyone's referring to the log4shell. I'll probably create a stream over the weekend on that as well. So as I mentioned, yeah, you can use OpenSSL for a bunch of things. You can also use it to sign and all that. But when I'm dealing with the web servers, that's basically what I use to look. With Connect, you can also download the S client. You can also download the chain. So what you want to do is just do a man on S client. And you can actually see all the options. You can try connect with different protocols, such as TLS 1 or 1.2 and so on and so forth. I recommend you just go have a look at this. You can also use it to verify certificates. But, I'll try create a cheat sheet on this at some time as well. So one thing that I did do, remember I should have had this prepared. Sorry, get hub. I created this tool called X509 Parser. Now, the reason why I created this is OpenSSL is great, but you can only really read, and if someone knows better than this, please let me know. But when you're reading in a X509 certificate, you can only read in a single entry. So one of the reasons why that's a problem. So if you go into I think it's SSL on Debian, and you're looking at things like Certsh, there is a file here called, remember what it's called. There we go. The CA.certsh folder. So if you just do a cat on that, this contains all the X509 certificates that are trusted by the system. Now, if you want to parse this file, you can't really do it with OpenSSL. At least I don't know of a way of doing that. So I created this little utility, this Python utility called X509 Parser. And basically what it will allow you to do is just run it so you can connect to site and get a bunch of certificates. But you can also run it against the file, and it'll actually parse all the certificates from that file and allow you to then view what certificates are in a file. So in this case, I could run against this and get all these certificates from this file. And yeah, it just makes life so much easier. It's one of those things where I wanted to learn a bit about Python, and I had this problem, so married the two. Actually see if I can quickly get it running. It's not going to work in there. Get clone. See if I can quickly get this running. I don't know if it's going to work. I don't want to spend too much time on this. Oh, why is that now working? Copy. Paste. Put 3. Hopefully this won't take long, and it should. This installed. Oh, I already had everything. I'm just gonna remember how to use this. Sorry, it's been a while since I used this path and then the file. And I think -f, and then we want this file. Yeah. Oh. Phew. Hopefully this works. I don't know what went wrong. I'll have to have a look at that later. Maybe I'm going to update the script. As I said, it's been a while since I've run it. Yeah, try one more time. I think this is still in Python 2. Eek. Should update it at some point, I guess. Try one more time. Yeah. I'll sort that out. But yeah, that's the whole point of that. I think it only works in Python 2. I think I actually even said, oh no, only supports Python 2. Maybe there's something wrong with OpenSSL. Yeah, so Top says NetTools. Yeah. I'm still curious why that's not working. It's gonna annoy me. I'll have to have a look. Okay, so that's that tool. A really cool tool is SSLs. I think that's installed. So this is where you can start in using this tool to actually test a server. So what you need to do is, I think it's just running against a target. So in this case, let's go against my blog site. I think that's all you need. So this will do a bunch of checks. So I'll check like the certificate's valid. It will check against supported Cypher suites, which I'll go over soon, quickly. And then it's got all the other information. So it's things like the information about the certificate, the chains, all of that. Now, the Cypher suites are the next important part on a TLS connection. A server can support X amount and a client can support Y amount. Why is this there? Well, the server has different operating systems, the client has different operating systems, and each may support only a subset of one the other. So you're talking like maybe a bit older clients and a newer server, or vice versa. So you have this set of what's called Cypher suites that both the server and the client has, and then as part of that protocol handshake, the TLS handshake, they agree upon a Cypher suite to use for that communication. And the Cypher suite actually defines several parts. So the first being this bit here, so like RSA or ECDH RSA. This is the key exchange. Now, yes, TLS is public key encryption, but beyond the initial handshake, it's no longer public key encryption. What it starts doing is using symmetric encryption. So where a key is used to encrypt and decrypt the traffic. The public key is used for the initial bits, so there's things like certificates, as well as the key exchange. And that key exchange is both where the server and the client come up with the key, that same key that they both need in order to encrypt and decrypt the traffic. Now, there's different reasons why you want to use one or the other. Diffie-Hellman, DH, so anything with a DH in it is the preferred option. RSA is the older way of doing it. And one of the problems with RSA is a concept called perfect forward secrecy. And this is a problem with RSA because it doesn't support it. And the reason why it's an issue is with perfect forward secrecy is the client and the server don't actually know the key. There's mathematics behind it. So one can't just start decrypting everything and storing that key somewhere to keep the exchange. So if I'm doing like a packet capture, I can't then suddenly down the line start decrypting that. So it's part of that perfect forward secrecy. With RSA, both the client and the server will have the actual key used within that protocol and exchange. So, or the encryption's encrypted with that same key. So, if you do like a packet capture and you manage to get that key, you can then decrypt that packet capture. With Diffie-Hellman, that's with perfect forward secrecy soft suites, that's not possible because you only have part of the key. It's got a whole bunch of mathematics behind it, but that's the point of perfect forward secrecy. So the encryption, the network traffic is really just for that transmission, and it doesn't live beyond that because it's not possible to get it or decrypt it off that. So that's part of the key exchange. And as I mentioned, like once the key exchange is all done, the next bit is the symmetric encryption. So once the client and server have validated certificates, agreed on a key exchange, also the protocol, so TLS 1, 1.1, 1.2, 1.3, hopefully not SSL because SSL should be dead, nuked, which SSL it has many vulnerabilities, so don't use that. So once I've done all of that, the next bit is actually doing the encryption, and that's where the symmetric cipher comes in, and that's defined by this. The next bit in the cipher suite. So it defines the symmetric cipher algorithm. So in this case, AES. So the ones like this, cha-cha-cha, 2020, poly, whatever. That one. And then in terms of AES, this is the key length. So the private key, that encryption key for this AES would be 256 bits. In this case, 128 bits. And then this is the mode of operation. Because it's a stream cipher, it has different modes of operation. And then the last bit is also quite important. So this is the MAC, so the message authentication code. So imagine I'm sending all this traffic, it's encrypted, that's great. Well, if I'm an attacker, I could just start changing things. Yeah, it might not, I can't get anything from that encrypted traffic, but if I start changing things, well, then the client may or may not even be able to make use of that traffic, or they might be able to change it in a way, probably really far-fetched, but that's what was originally sent doesn't match what was received. So this MAC, this message authentication code, is a way that the client can validate that this traffic, this encrypted traffic, hasn't been tampered with. And you want to use things SHA-256 or SHA-2 and above. SHA is old. There's different collisions that you can do. It's pretty far, but it's still technically possible. But yeah. So yeah, there's things like, as I mentioned, forward secrecy. Legacy RC4 is bad. Don't use that. And then yeah, TLS 1.3 is the latest protocol, and it's the one that start looking to use. And then there's all these other things that SSL LAS reports on, so all these different vulnerabilities out there. And then there's also like compliance things and all that they can check against. So that's SSL LAS. Another tool is SSL scan. I think it's just also that. So this probably prints it in a bit prettier, so you can see color there, and it's a bit simpler. So it tells you what protocols are supported, other things like can you do your SSL renegotiation? You probably don't want to do that. Heartbleed and all of that, just supported Cipher suites, a little bit about the certificates. The next tool that I recommend is testssl.sh. So in this case, there is a Git repository that I always lose sight of. Here we go. So what I do is I just clone this. Thankfully, this should work better than my my tool. So if I clone that, actually go into it once it's cloned. This is actually a really great tool. And then you can run test SSL, and then Certsh, and away it goes. And again, it does the same thing, just in a different way. Now, I sometimes run multiple tools because you get a broader coverage that way. Some of these tools test for one thing and other tools don't. So in this case, like you can see things like triple des. Triple des is bad. So you shouldn't be using it, whereas the other tools didn't really pick up on that. And that just gives some additional information. So I generally like use one or two or three of these tools just to have better coverage. And then, yeah, so it gives you all this other juicy information, much of the same as the others, but some of it is a bit different. So just going through it, so all the Cipher suites, the kind of weaker Cipher suites that you may be supporting, that shouldn't be good. So that one is CBC. CBC has known vulnerabilities, not the end of the world, but still. Just heads up, this is Cloudflare, so I don't have much control over this. And this is the other thing you might have some issues with some of these tools, even clients running against you, is things like Cloudflare or AWS CloudFront. You have kind of limitations of what you can enable and disable. Like a lot of the Cipher suite, you pretty much have no control over those. So it's whatever they offer. Certainly servers like Apache and that you then have full control over this. Yeah, so supported protocols, supported Cipher suites, forward secrecy, so testing that out, extensions and other information. Generally, you're probably just looking for supported Cipher suites, supported protocols, and any of the vulnerabilities that it can detect. All of this stuff is other kind of information that's interesting, but not absolutely necessary. Obviously, expired certificates and certificates that don't match are also important. Yeah, so these vulnerabilities are the next important bit. Yeah, and I think it also tells you which clients actually support it, which is actually also a pretty cool feature. So good. Sorry if you're using XP and IE 8 and below, you can't visit my site. But yeah, this kind of stuff is pretty useful. And and then it gives a rating. Now, ratings are pretty useful. I'll show you a really good tool from Coiler that kind of, I guess, kickstarted this off to the best of my knowledge. So, as I mentioned, there's a tool, a Coiler Store, tool online. They do have a CLI command that you can use to run this, but most people just run it via the web. So it's a scanner. So yeah, they have this. Now they have as I said, they have a bunch of tools that you can use. So you can use this server test is this online one. They have like a client test that you can also run. So let's actually run this. This will test against my browser. So away it goes, testing things against my browser. Okay, so my browser supports weak Diffie-Hellman, so it's vulnerable to logjam, and it supports all of these. Again, I don't have much control over this stuff like Firefox owns, but it's not too much of a concern. It's more server-side concerns. So yeah, it gives you all this information about your browser itself. They have APIs, so you can like call out APIs, and they have all these other things. I haven't really gone through this much recently, but yeah, it's there. Go have a look. So, if you want to scan my site, off it will go. If you're scanning typically like a fronted thing, so like Cloudflare or AWS CloudFront, or if it's like load balanced, you'll see that or detect that it has different RPEs associated with it, and it will go off and scan each one. Also, just coming back to this, if you are scanning probably your company, you probably just want to tick that so it would then show up on these boards. So you don't be like one of these. So let's let it go off and scan its thing. It might take a bit to scan. So while it's doing that, there's another online tool called UniWeb. They actually have quite a few cool stuff. So they have this SSL security test. Again, very similar to Qualys. You just enter in the site. Again, you can put in the check to don't show it on the board. UniWeb also has a bunch of other scanners, which is pretty cool and free. You can scan mobile apps. You can scan sites. So you can do like a very lightweight website scan. All that stuff's pretty cool. Let's see. How far did it get? Let's close all those. Okay, so yeah, I got an A+. A+ is the best. And then T is bad. So you get all these nice graphs, so showing you how good your certificate is, how good your protocol, key exchange, cipher suites, and all that. I think you can also download this, or if you want to, you just print this out as a PDF. That's normally what I do. So yeah, again, much like the tools that I ran, gives you information about the certificate, all this good stuff. And this is where I was mentioning the change. So this is the service certificate here. This is in turn signed by this certificate, which, no, wait, I'm getting myself confused. Maybe it's not presenting the full chain. Normally presents the full chain. That's weird. Anyway, it can also show the full chain, yeah. Here's the supported protocols, supported cipher suites, and it's nice to color codes the ones that are a bit weaker. And I think, yeah, if you go right to the top, you can also view more information. It gives you a bit more information about it. So if you have something really bad, it will show up there. List all the clients that would be supported, and then the different kind of vulnerabilities that you have. Yeah, So much like the tools that you've run locally. And then, as I said, it also gives you a nice score. And it'll go off and scan all the different servers in the back. So UniWeb has something also pretty cool. It tells you the different kind of compliance if it passes those. This is where I was thinking about. So SSL Qualys, you just go file print it as a PDF. UniWeb, you can actually like download as a nice PDF. Subtle touch, makes it pretty cool. This is another cool thing. It actually goes off and finds other domains. So yeah, you can just go to log in. You can create a free account and you log in. It'll show you those. And then you can actually also then view those certificates with those other subdomains. Certificate information. So we've gone over this. This is cool. So this is actually showing you the chain. So there's the root CA that in turn signed that, and that signs that, and the CA signs that. That's pretty cool. It shows you that. So this test for PCI DSS, so the supported protocols and cipher suites, the elliptic curves, all of that stuff. So elliptic curve is more with TLS 1.3. And then all the different vulnerabilities. Same with HIPAA, and it gives you other like industry best practices, all that cool stuff. So there's quite a bit of cool stuff on this. And then, as I said, with like community edition, you can do all these other scans, which is pretty cool. But that's not what this is all about. So just going through. The other thing I wanted to show you is that certificate transparency logs. So there's a site called Certsh, and this kind of utilizes those certificate transparency logs. So if I just search SeanWright.com, should be able to find certificates associated with me. So there we go. You can do this. This is all public information. So as I said, when something issues a certificate, it's going to put it in the certificate transparency log, and this is a tool that allows you to query that. So in this case, you can see all the CTs. It also contains CAs in here as well. So if you want to go view the certificate here, you can see the certificate itself, details of the certificate, so the actual certificate. And the other important things are the log entries. So this gives you like the log URL. So this kind of showing you the actual log when it was logged. I think you could use a tool or something to query that. But yeah, and all that good stuff there. I think there's also sometimes these are, I can't remember if it's these. Yeah, so there's a pre-certificate. So this kind of when it starts, this is the kind of entry into the CT log. And there's the certificate itself. So you can search all of this, and there's a whole bunch of stuff that you can find here. And this is really useful for also detecting subdomains. So this is one of the problem with CT certificate transparency, and whether you use public certificates or public meaning third-party CA signs that and publishes it to a CT log, because you can now start getting all the subdomains for that domain, or certificates issued for a subdomain for that domain, publicly issued. So it's a good way of also then getting open source intelligence on a domain. So you can then use that to work up subdomains. So yeah, there's all those, all my Let's Encrypt certificates that you can see I've been requesting. So that's CTLogs. So CTLogs, there are tools that allow you to sign up. I forgot the one that I used a while ago, but Facebook actually has. Um, I think you have to have an account. But here's some information. Yeah, if you are interested. Yeah, you gotta have an account. But what if you do have a Facebook account, you can log in and you can actually issue a or put a domain. So whatever domains you want, and it will send you notifications and that when new certificates come about. I can't remember. So if anyone remembers, it'd be awesome if you leave a comment in it or a note in the comments or something like that. I'm sure also if you just search for certificates, transparency. Yeah, I'll have a look. I'm pretty sure there was another service that I used, and I forgot what it is. Oh, Cloudflare actually has one, which is pretty cool. So if you have a Cloudflare account, you can go off and get CT monitoring, certificate monitoring. But yeah, there was a really good one. I can't remember. So some other cool thing is you can use things like Census. So you can actually also use Census. This also leverages CTLogs, and you can actually search for certificates from them. So let's see if I can actually find myself. Hopefully I don't have to sign up because you got to sometimes sign in. I always get this wrong. You got to get the whole thing. But if I just search for it should find that. There we go. So with the DN, you got to get the exact line right in that. But you can use Census to also search for certificates, and you can get the certificate itself. You can view the trust and the different entries, and you can view things like CTLogs. All cool stuff. So that's and you can also use Showdown. Showdown, you can also search for certificates. So other thing is that I got on my list is so I've mentioned X509 certificates. So that's one format. Another format is PKCS. It's not really used that often, but again, you can use a tool, something like OpenSSL, to then convert or even view and even create those certificates. And then the other tool or format is JKS, Java Key Store. A Java Key Store is a Java format. So anytime Java is using certificates, in fact, you should be able to see this on here, I think. Let's see. Gets here. Maybe I don't have Java installed. LSL. So there are .jks, Java Key Store. No. Maybe if I install open JDK. So I think this should place it. So the OS also has a trust store that's in JKS format, and this is what your Java virtual machine will use as its trust store, and it's a collection of certificates. I think it's normally in Java. got it. It's normally somewhere. Let's see if we can find it. So, yeah, as I said, this is a format that the Java virtual machine uses, or Java users, and that it's used to hold things like anything from signing certificates, trust stores, to even private keys / service certificates. So let's see if we can find one. This is weird. So JDK folder. Yeah, there's normally. So there should be so security policy. It's been so long since I looked at all of this. Yeah, I know. So, like with Ubuntu and that, if you install CA certificates, it has the JKS kind of bundled with that, and it's a really good way. It makes life so much easier if you're managing it from a corporate environment. You just have one JKS that you then need to manage versus a trust store. Because with Java, you can have either leverage the one that's defined by the JVM, or you can actually specify your own. And this is where it really can get pain in the behind, because apps will then have their own trust store, and then how do you manage like 5 different trust stores on the system, or even know where they are, which one it's using. So it's much better to have one trust store, rules them all, and then that's the one that you manage. Because if there's a rogue CA, you want to quickly pull that CA out of the trust store. I'm just trying to remember. Let me see. Just do a search. Debian Java Trust Store. Just trying to find out where it is. Yeah, it's normally in the lib security CA certs. I forgot it's not the. There we go. I forgot. I thought it was this. Missed the subdirectory Java. So yeah, it's not .jks. So sometimes people name it .ts trust store. The CA cert is the Java trust store and doesn't have the .jks extension. Certsh Java. If you're using something like Oracle JDK, it's in this directory with the so if you go look at, there's a JRE subdirectory, then lib security, and then there's a CA certs. But in this case, using something like OpenJDK, it's nice. They're part of the OS. So the cool thing is, actually, I can show you this in a bit as well. There's a nice way of managing CA certificates at an OS level. So you just, again, managing one thing. So the way you do this is there's a tool called Keytool, and this is what you use to work with Java certificates. And goodness me, it's been so long since I have used this. So I'm very rusty, so apologies if I forget things. Minus list. I'm sure it was minus N. I'm just trying to remember how to use this tool. Sorry. I used to know these commands off by heart. No, I don't. Minus list. I think I just. Sorry, I gotta find this cool. This. Apologies, I used to know these offhand. I'm gonna use a a cheat sheet on this key store. So, interesting thing with key stores is it will ask you for a password. Now, there's a password on the key store itself. Think of the key store as like a vault, so you can add and remove things in that key store. It also holds keys, public keys, private keys. So the key store itself has a password. Now, I didn't know this after some time. Is with the default one, it's I think it's change it. Yeah. So if you enter it, you can see all of this. This is fine. That password is important if you want to add or remove things. Now, if you don't provide a password, it still works. What it'll do is just show the public information. So anything that's public with the certificates. So in this case, listener key store, it's the same. But I can't modify it without that password. And again, you have a key pass, which is specific to an entry in there. So you basically can have two passwords with the key store password itself, and the key pass, so the actual password associated with that specific entry. Now, in here, you'll see all of these have a trusted cert entry. So this means it's a CA or a certificate that's used for trust. There's a private key, I think it's called private key. And yeah, you can view that there. Now, these each have a notion of an alias. I think I'm going off memory here, so please forgive me if I am not good with this, but I think the alias is that. So you can just filter down to one. Yep. So each entry has an alias, so think of it like a friendly name. And then you can also do a -v to do V for verbose, and it will start printing out more information about that certificate, which is good if you want to start querying a specific entry. Now, as I mentioned, one of the cool things is there's a package called CA certificates. So CA certificate. This is with Debian-based things, so Debian, Ubuntu, that kind of thing. Fedora or Red Hat has its own similar thing as well. So yeah, here's the CA associated with Java. Now, if you go into, I've got to remember the right directory, so just 1 second. I'm just looking this up. There is a directory that you place any certificates that you want to add into the directory. Then you can run this tool called CA update, and then it will actually import that certificate into all your OS trust stores. So things like your Java key store as well as your OS level trust store. So that means you run this one command, it's in all the different things. So that's where I was saying it's becomes a lot easier to manage. It's just a single point. And I think you can also remove things. I'm not too sure of the command to remove it, but let me just find it, this example, and then I could just show you quickly what it looks like. So it's in. Let's go find it. Yeah. So if you go into user local share CA certificates. Now you'll see this directory is empty. I am just going to find a certificate. So I have a internal CA certificate. Unfortunately, I'm not going to show you that certificate because that's specific to my network that I don't want to make public. But I can certainly show you the import itself. So I'm just going to call this, sorry, copying this. Yeah. I'm just going to copy this. Wait, why is that not working? There we go. No, copy. No. Why is it? Why is this not working? Oh. Just try to get somewhere that doesn't have all that. Documents. There we go. Ah, there we go. All right. So if I now do a sudo copy documents, so you can now see there's a CA certificate. Now what you do is run update CA certificates. And there we go. Simple as that. And what that's done is now added this CA into all the OS level trust stores, so including that Java key store as well as all the other kind of X509 certificates. And you can also remove it. I don't know exact command, but you can also use it to remove things. So as I said, really good way of managing CA certificates. And with that, I think we've come to pretty much an end. Thanks for everyone who attended and participated. Apologies for the delayed start. Hopefully I'll work out all my technical glitches, so next time I won't be so late again. But yeah, and just quickly going through sorry, I'm just reading through the messages. So yeah, Solve has a good point there. So with bug bounty tips, GitHub docs for finding JKS files. So you could find things like passwords in source code near it, or sometimes they don't set a password on it. Unfortunately, sometimes they do set a key on it as well. Oh, that is one thing I really forgot. With certificates, so you have the certificate itself. I think if I do this should be a good example. So yeah, actually I don't have it on hand. But if you install like Apache or something like that, I just don't know if Apache is installed yet. There it is. I think if you install mod SSL, been a long day. Where's mod SSL? Because I want to show you the difference between a private and public key, because this is really important. If you don't protect the private key, you're kind of wasting your time. This should hopefully install it. I'm hoping. Hopefully Apache to SSL. Let's quickly look. Debian install Apache to SSL. So with Apache HTTPD, there's a module plugin called SSL. I just got to remember what it is. Will this work? Let's see. Okay, I read it. Sorry, brain is going. Yeah, so if you go look in security docs, I think it's not reconfigured yet. Oh, it's in the certs. There we go. That's what I was looking for. So if you look at this default ssl.conf, generally when you install it here, you'll have these what they call like the snake oil, which is a cell sign certificate, just so you can run it. So if I think it's running now. So if we go to HTTPS localhost, just making sure I'm not using burp. You should get like a certificate issue. No. So there we go. Ooh, I don't know what that is. That's something else. Anyway, don't know why it's doing that. Something with the configuration. But you'll see, as I said, you'll see these certificates there, and this is where you configure the certificate. So if you're standing up a proper certificate with Apache, you would define your own certificate, add key. So this is the certificate. So if you view this here, and we use OpenSSL to view it, so it's X509 certificates, and we'll just print minus text. So there we go. We can view the certificate there, and that's all the stuff about the server that I'm on. Nothing interesting there. If we view this is now the private key. So you can actually cat it, and you'll see this is a bit different. And as you see, it is not readable to me. And as the name suggests, this is private. This is the parts that you don't want to share with anyone. In this case, I'm not too worried because this is just a test system and this is a signed certificate that I'm never going to use externally. But with this private key, what someone can do is take that certificate, stand up their own server, and now present it as the server that the client then is connecting to. And this is how you can do interception if you have that private key. And the client will not know any difference between the legitimate server and anyone pretending to be the legitimate server. Because as far as the client's concerned, it's connected to that server, it's got the valid certificate that says it's that service, and away it goes. So this is why you have to protect this private key. Absolutely vital. You have this private key, the TLS connection's insecure. And you should be able to also query this. I think you can use RSA, and much like most things, and then use minus text and give you information about it. I should use no art, but then it gives you some information about it, more mathematics around it. But yeah, that's the private key. So have to protect that. Make sure it's readable only by the user that needs access to it. Cool. All right. So hopefully everyone had an enjoyable time and this was somewhat informative. And yeah, thanks for joining. I will probably be covering the Spring for Shell stuff on the weekend, hopefully. See if I have time. But yeah. And thanks to all those who attended. And catch you in the next one. Bye.